At 7:05 p.m. on July 17, 1981, 1,700 people were dancing in the Hyatt Regency Hotel Atrium in Kansas City, Missouri. Suddenly, two massive walkways suspended above them collapsed in sequence. Within seconds, 114 people were dead and 216 were injured. This was the deadliest structural failure in United States history until September 11th. This is the official investigation into what went wrong. The Kansas City Hyatt Regency opened in July 1980 as part of the Crown Center development. The signature architectural feature was a massive 4-story atrium with 3 suspended walkways. The second floor and fourth floor walkways were directly stacked above each other, hanging from the ceiling by steel hanger rods. The third floor walkway was offset to the side. The hotel marketed this dramatic open space as perfect for large gatherings and events. Here's the official location where this tragedy occurred. The Hyatt Regency stood at Crown Center in downtown Kansas City, Missouri. The hotel's atrium measured 117 feet long by 62 feet wide. The walkways suspended across this space connected the hotel's towers. On the night of July 17th, the atrium was hosting a weekly tea dance, a popular social event that regularly drew over 1,000 attendees. The original design called for the walkways to be suspended by continuous steel hanger rods running from the ceiling through the fourth floor walkway down to the second floor walkway. In this design, each walkway's weight would be independently supported directly from the ceiling. The engineering firm Gillum Colico Associates calculated that this design could safely support the walkways plus the weight of people standing on them with a built-in safety factor. But during construction, the steel fabricator made a request. Installing continuous 30-foot-long rods through both walkways would be difficult. They proposed a change. Use shorter rods with the fourth floor walkway supporting itself and the second floor walkway hanging below it. The engineering firm approved this change with a simple stamp on the revised drawings. Nobody performed new calculations. This single decision doubled the load on the fourth floor walkway's connections. It was a fatal mistake. Every Friday night, the Hyatt Regency hosted a tea dance in the atrium. By 7 p.m. on July 17th, approximately 1,700 people filled the space. Many stood on the second and fourth floor walkways to watch the dancers below. Witnesses later reported the walkways were packed shoulder to shoulder. Some noticed the walkways swaying slightly as people moved. Nobody suspected the structure was already at its breaking point. The combined weight of the crowd, the music, and the slight movement was pushing the overloaded connections past their limit. The critical connection point, a box beam hanger rod assembly on the fourth floor walkway, was under immense stress, double what it was ever designed to handle. A small crack, a groan of metal, was the only warning before the catastrophe began to unfold. As the music played, a loud crack echoed through the atrium, but many dismissed it as part of the band. It was the sound of the box beam connection on the fourth floor walkway giving way. The hanger rod tore through the steel beam. This initiated a progressive collapse. As one connection failed, its load was transferred to the others, which were already stressed to their maximum. One by one, in a catastrophic chain reaction, the connections failed along the entire length of the fourth floor walkway. Within a terrifying instant, the entire structure dropped. The fourth floor walkway, weighing 64 tons and packed with people, plummeted onto the second floor walkway directly below it. The impact was immense. The second floor walkway, unable to withstand such a sudden, violent load, collapsed immediately. Both massive concrete and steel structures, along with everyone on them, then crashed down onto the crowded atrium floor below. The sounds of music and laughter were replaced by a deafening roar of twisting metal and shattering concrete, followed by an eerie silence, broken only by the screams of the injured and the trapped. The immediate aftermath was a scene of utter devastation. Survivors on the ground floor were crushed under tons of debris, the air filled with thick concrete dust, making it almost impossible to see or breathe. The hotel's sprinkler system activated, drenching the wreckage and the victims in water, adding to the chaos and danger of electrocution from severed electrical lines. First responders arrived to a scene they could only describe as a war zone. Firefighters, police, and paramedics were met with a tangled mass of steel, concrete, and human bodies. The rescue operation was incredibly complex and dangerous. The remaining third-floor walkway was also feared to be unstable, threatening the lives of the rescuers working below. Engineers were rushed to the scene to assess its stability. Heavy machinery, including cranes and jackhammers, were brought into the atrium to lift the massive slabs of concrete, a delicate and slow process. Doctors and nurses from nearby hospitals rushed to the hotel to provide on-site triage, performing amputations and other emergency procedures right there in the wreckage to free trapped victims. The rescue effort lasted for over 14 hours. Once the rescue was complete, the investigation began. The National Bureau of Standards was tasked with determining the cause. They meticulously collected and analyzed the debris, focusing on the failed connections. They compared the AS-built structure with the original engineering blueprints and the shop drawings. The key piece of evidence was the modified hanger rod connection. The investigators found the box beam from the fourth-floor walkway was horrifically deformed. The steel around the hanger rod hole had been torn through, proving it was the point of failure. Their conclusion was unequivocal. The fatal design change was the direct cause. The original single-rod design would have easily supported the intended loads. By changing to a double-rod system where the fourth-floor walkway supported the second, the load on the fourth-floor connection was doubled. This concentrated stress was more than the box beam could handle. The engineering firm, Gillum Colico Associates, had approved the change without recalculating the loads, a catastrophic failure of due diligence. The steel fabricator, Haven Steel, had proposed a change for convenience but wasn't responsible for the engineering analysis. The blame fell squarely on the engineers. The legal and professional consequences were severe. Lawsuits totaling over $3 billion were filed on behalf of the victims and their families. The lead engineers, Jack Gillum and Daniel Duncan, lost their engineering licenses in Missouri and other states. Their firm, Gillum Colico Associates, lost its license to operate as an engineering company. The case became a defining moment in engineering ethics, highlighting the critical importance of communication, accountability, and the need to double-check every calculation, especially when design changes are proposed. It's now a standard case study in engineering schools worldwide. The Hyatt Regency Walkway collapse served as a wake-up call for the entire construction industry. It led to significant changes in building codes and professional practices. The concept of constructability, ensuring a design is not just theoretically sound but also practically buildable, became a major focus. It emphasized the need for clear communication and a defined chain of responsibility between architects, engineers, and contractors. Every proposed change now requires a formal review and re-verification by the engineer of record. These changes, born from tragedy, have undoubtedly made modern buildings safer and saved countless lives. The hotel itself was repaired and reopened just a few months later, but a memorial now stands in a nearby park. Here's what the official records reveal about the tragedy. At approximately 7:05 p.m., the box beam connections on the fourth floor walkway failed. The fourth floor walkway fell onto the second floor walkway, and both crashed into the crowded atrium below. The National Bureau of Standards investigation confirmed 114 deaths and 216 injuries. This made it the deadliest structural collapse in US history until the September 11th attacks 20 years later. Survivors described hearing a loud crack followed by the sound of tearing metal. The fourth floor walkway dropped first. As it fell, it collided with the second floor walkway directly below, ripping it from its supports. Both walkways crashed onto the crowded dance floor. 65 tons of steel, concrete, and glass fell 4 stories. People on the walkways and those dancing below had zero time to react. The atrium instantly transformed into a disaster zone. Kansas City emergency services arrived within minutes. First responders found a chaotic scene: twisted steel, shattered glass, and hundreds of injured people trapped under debris. The rescue operation lasted through the night. Doctors and nurses from nearby hospitals rushed to the scene to provide emergency treatment. The atrium's remaining third-floor walkway stayed intact, allowing rescuers to access the disaster area. The last survivor was pulled from the rubble 14 hours after the collapse. The National Bureau of Standards immediately launched an investigation. Engineers examined the collapsed walkways piece by piece. What they discovered was shocking. The box beam connections had been loaded to 91% of their capacity under normal conditions. When people crowded onto the walkways during the tea dance, the connections exceeded their design limits. But the real culprit was the design change. The modified connection system was only at 60% of the strength required by building codes. Here's the verified engineering analysis that explains the failure. This diagram from the official NIST report shows the critical difference between the original design and the AS-built configuration. In the original design, each walkway connection carried only its own load. In the modified design, the upper connection carried double the load, supporting both walkways. The investigation concluded that the modified design was fundamentally flawed and never should have been approved without new structural calculations. The legal consequences were severe. The engineering firm's project engineer and the structural engineer both lost their professional licenses. The first time in Missouri history that engineers were disciplined for a structural failure. Multiple lawsuits resulted in settlements exceeding $140 million. The Missouri Board of Architects and Engineers found that the engineers had failed to properly review the design changes. The case became a landmark in engineering ethics and professional responsibility. What did the engineering community learn from Hyatt Regency? First, all design changes must be recalculated by qualified engineers even if they seem minor. Second, clear communication between designers, fabricators, and builders is critical. Third, connection details matter as much as overall structural design. Fourth, professional engineers have a legal and ethical duty to verify that their designs meet code requirements. The Hyatt Regency collapse fundamentally changed how engineers approach responsibility and oversight. Could this happen today? Modern building codes now require independent structural review of critical connections. Computer modeling allows engineers to test designs before construction begins. Professional licensing boards have stricter continuing education requirements. However, communication failures between design teams and contractors still occur. The Florida International University bridge collapse in 2018 killed 6 people due to similar connection design errors. The fundamental lesson remains: structural engineering requires constant vigilance. Small oversights create catastrophic consequences. 114 lives lost. A single design change never properly reviewed. The Hyatt Regency disaster proves that structural failures aren't just about bad luck. They're about human decisions and professional responsibility. Subscribe to Collapse Report for more verified engineering investigations. Next week, we analyze the Tacoma Narrows Bridge collapse, the structure that destroyed itself in just 4 months. The physics are incredible and terrifying.